This video is some highlights from a live session I did painting an abstract geometric piece on TikTok. The piece is inspired by the opponent process theory. That's a theory that says there are two main oppositions of color that structure human color vision: the blue-yellow opposition and the red-green opposition, which is really focused more on like magenta and turquoise. So I chose 4 pigments that I thought would be interesting to experiment with and which would demonstrate those two opponent axes, and which also had some interesting mixing properties. I answered some viewer questions and, well, I hope you enjoy.
I just got this in the mail. This is a neat pigment because by itself, it's not super high in chroma. It's actually almost like brown. It's like an ochre. But as soon as you throw a little bit of white into it, it flares up and it becomes this bright, vivid yellow. It's one of those few pigments that is more chromatic when you add white. So another one is actually this one right here, quinacridone magenta. This is a very chromatic red-violet, but when you add a little bit of white, it actually becomes more chromatic. My other 2 colors are Cobalt Blue Deep. This is another new one in my collection. I've been itching to get my hands on this for a while. I'm not really a huge fan of Cobalt Blue PB28, but this is PB74. This is more of a blue-violet, and let me just open it up so you can see for yourself the depth of this color here. It's close to ultramarine blue, but it mixes a little bit differently. And the 4th color in today's palette is Cobalt Teal Greenish, the color that I've been gradually falling in love with over the past 6 months or so. So Nickel Azo Yellow, really cool pigment. Check out what happens here. We're gonna mix a little bit of white. As you can see, it's almost ochre-ish when it comes out of the tube. Also almost slightly has a green undertone, as you can see if I kind of smear it out here. But I'm going to throw a tiny bit of white in, and we're going to see its character change. It's a transparent pigment, and when you add white in, it gains opacity, obviously, but it also gains chroma. It starts to appear almost like a bright, vivid yellow. You can see what I mean here. Ochre will not do that. Yellow ochre, when you add white, just gets pastel. Whereas this guy behaves strangely. You know, I've really adopted this this credo that done is better than perfect. And that's helped me to be a lot more productive recently, because I can be the same way. I have a lot of unfinished projects, not just paintings, but all kinds of creative projects. And you know, perfectionism is the enemy, I think. Anyway, there's this whole school of thought that actually we've got to be talking about 4 primaries because of the way we perceive and talk about color. Those primaries, the psychological primaries, are often called blue, yellow, green, and red. Blue and yellow being one opposition, right? They kind of come in these pairs that oppose each other, and green and red being the other opposition. And so this idea that there are these 4 psychological primaries has always been kind of intriguing to me, and is kind of the basis for this painting. So we're going to start with the 4, and then we're going to do a halfway blend between each pair. But then I'm also going to go across and get like these kind of neutralized low chroma mixes, which are going to go in these areas in the center. So that's the plan. There it is. Look at that. Who would have thought that beautiful, bright, warm yellow would come out of, right? When it came out of the tube, it looked like a dark ochre. We're going to throw some Cobalt Teal Greenish. This is PG50. This is not a cheap pigment. This is one that I actually held off a long time on buying because it was so expensive. Not only is it like the brightest blue-green I've ever painted with, it also mixes really nicely, which is surprising because most cobalt pigments I find do not mix very nicely. Cobalt violet, cobalt blue, they tend to be grainy because the pigment particle size is very large, but also they don't integrate nicely. So you could be mixing and mixing and mixing on your palette, but it's still like doesn't quite integrate, or even in the case of Cobalt Violet Light, It's a beautiful like fuchsia type color, but when you try to mix it into other colors, it like disappears, it gets eaten. I am now going to attack this green area because I want to show you just how magical this is going to be. When we put the cobalt teal and the nickel azo yellow together, I'm going to pull this over here actually and grab a little bit of my nickel azo yellow to start, not too much, and see what kind of a green we get. That's already like awesome. I think I might add a little more of that yellow in. Again, like this is just magic to me because you expect a color that looks like ochre to go into a color like this cobalt teal and almost give you something like a chrome oxide green, like a dull sap green or something like that. But it gives us this crazy bright green. So here we go. I'm going to put a little more yellow in. All right. Pretty happy with that. I'm just going to get a little solvent in there and loosen it up. My support, by the way, is a birch panel. You can see the grain on the back here. On this, mounted on this, I guess, chipboard ring. You can get them on Amazon. But I primed it with gesso, with like a gritty gesso, a gesso that has a little bit of a tooth to it. And so it has this nice texture. I don't know if you can see that if I kind of dry brush over here. But that texture is something I made by hand by actually taking a piece of styrofoam and preparing the surface. This is Sakugari. You talked about psychological primaries. Is it biological or a philosophical concept? So that's a great question. It actually kind of started as a philosophical concept, if I recall correctly, and the first guy to really articulate the theory was this guy, Ewald Hering, and he totally didn't agree with the whole theory that there were three receptors in the eye and that red, green, and blue were the primaries. If you think about language and just the way people conceive of color, you never hear somebody describe a color as like yellowish blue, right? He's saying you never hear someone say yellowish blue or greenish red. Right, so there seem to be these pairs of color that are just fundamentally opposed. We might describe a blue as reddish, we might describe a green as bluish, but we would never call a blue yellowish, and we would never call a green reddish. He kind of like worked it out that blue and yellow and green and red create these two axes that this painting is actually kind of inspired by. So the funny thing is that it turns out that even though he proposed that theory in opposition to trichromatic theory, this idea that red, green, and blue are the primaries, it turns out that like both theories are right. The second part of your question is like, is there a biological basis? And currently the theory is yes. The first stage is the sensor inputs. That's the RGB. But in the ganglion cells at the back of the retina, so before we're even in the brain, there is a series of basically like logic gates. They found that the way these nerve cells are wired together is actually in support of Hering's theory of four psychological primaries and basically two contrast axes. Right. So a lot of times in traditional color theory, they teach you that yellow and violet are opposites, but it's really yellow and this blue-violet. So this guy is going to go here, and then we're going to do a blend of the teal and the blue-violet here. This cobalt blue dark is pretty close to ultramarine blue, right? Some of you, if you're painters, you might come to that same conclusion, that if you're looking at this on the canvas, you're saying, what's the difference? And they're actually quite close. I think the only real difference might be their spectral profiles. My hunch is that it's probably not reflecting as much red light as ultramarine blue. All right, I'm going to mix my dark into light like a good boy. And let's see where we end up. And we're kind of past cerulean now, into strange territory. Usually you have to mix white in to phthalo or something to get a color like this, but we're not dealing with white here, we're just dealing with cobalt teal and cobalt blue deep, and getting this very interesting, opaque, light-valued blue here. All right, I dig it. All right, so far we've got 3 pigments in play, and actually I could do this one as well. So this is going to be a neutral that we're going to get mixing our nickel azo yellow and our cobalt blue deep. When you're dealing with yellow, which reflects most of the spectrum, including what people would call green wavelengths, right, the middle of the spectrum, and you're dealing with a blue, there's always going to be some overlap in the middle of the spectrum with the greens. So even though visually they are opposed, when you mix them, they're not going to go gray, they're going to go green because of that spectral overlap. All right, so the green that we get here, let's just throw a little bit on here. It's a very sap green kind of green. So I think I put a little bit too much solvent in my paint here, but I kind of think it was a happy accident because I like the translucency of this sap green that I ended up with. So I put a little bit of white into my magenta just because it's pretty dark when it comes out of the tube. I don't think I mixed enough paint. I underestimated the size of this area. Little solvent to the rescue. Loosen it up a bit. How did you decide on the shapes? What a great question. Thank you. I've been doing a series, of which this is a part, where I take a pigment chart that's published by Bruce McAvoy, where he kind of did all these scientific readings of the hue and chroma of different pigments. And so I took his pigment chart and I actually kind of ran the positions of the pigments through a Voronoi diagram generator, where basically if you have a field of points of just XY coordinates, a Voronoi diagram shows you where would the boundaries be that are decided by, if I sent out rays going in every direction, where would they touch? So, if there was a point here and a point here, the rays coming out of those 2 points are all touching along this line. And so it's a way to create cells and these pockets or boundaries. And I thought, wouldn't it be cool if I took that data about pigments and illustrated those cells that their coordinates produce by filling in those cells with the pigment. So I called it the Voronoi series, and I think this is number 7 or 8 or something like that. What type of school do I teach at? So I teach at a private school that's grades 6 through 12. And it's kind of a small school. I think we have about 600 kids overall. And I'm the chair of the art and design department there. So a lot of, the research that I've been doing into color theory doesn't just feed into the content I do online, it also feeds into my day job for sure. It kind of all started because of the pandemic, the color nerd thing. I was in my day job looking online for resources that I could send my students to learn color theory as part of our unit on color. And it was like everything was wrong, right? So that's kind of a main reason I started to get into publishing content online. So we have this interesting brick red. I think I am going to throw just a little bit of white in there just to see. It's easy to go too crazy. Ooh, I'm getting kind of a, ooh, that's fun. Wow, that really changes things. Wow. All right. Let's see how this looks. I'm going to loosen it up with a little solvent here. I like it. It is kind of sanguine, isn't it? I've been finding recently that doing these kind of geometric paintings kind of hurts my eyes, and I have to take a break after a little while sometimes, because your eye focuses on these hard edges between two colors that sometimes are very highly contrasting, and it just kind of like, dazzles your eyeballs a little bit after a while. So I'm going to throw some white into my violet just because it's so dark. You can get pretty much the best purples and violets with quinacridone magenta. Quinacridone violet also mixes nice purples, but they're not as chromatic. And I've experimented a lot, and basically nothing can compete with quinacridone magenta for mixing purples. So this violet is probably lighter than I want. I might go in with another layer once this dries, but you get a sense of the capabilities of these pigments in terms of the purples that they can make. Cobalt blue deep, the blue that I used here, is not, in my limited experience, because I only got this paint the other day, is not really impressing me. Like, it's not blowing me away in terms of its purples. Yes, this last shape is going to be a mix of quinacridone and the teal. This actually might be a nicer purple than the other one, which is interesting, because this guy is so far away. Oh my goodness. Look at that. Look at that bluish purple. It's one of those colors. Purples are hard to capture on camera. They don't show up very well. So you're probably not seeing this purple as vividly as I am. It probably looks pretty dark, almost black or gray to you based on whatever your phone settings are, but to me, in person, it's a pretty decent purple. It's not like, you know, super high chroma, but it's certainly not neutral. It's certainly not a gray. Just like this moss green is not a neutral or a gray. And so, like, if you learn nothing else from me, I hope you learn this, that visual complements are not mixing complements, right? Just because two colors are opposite each other in hue does not mean that mixing them together will give you neutral. It just doesn't work that way. I think we want it to, but it doesn't. And a lot of opposite mixes will be green biased like this guy, purple biased like this guy, sometimes even blue. Thanks again for hanging out with me as I experiment with pigments and kind of chat a little bit about them. If you like seeing these kind of lives and think I should do them more often, let me know. I always enjoy hanging out with you folks and talking shop, talking about paint and color and all that jazz. All right. I think that's it. Yay, we did it. We did it. Yay. It's done. Thank you for the roses and the gifts. Thank you for your comments and questions. And I hope you all have a great day.